This is question 41 of Civil Engineering paper GATE 2014 afternoon session. A horizontal nozzle of 30 mm diameter discharges a steady jet of water into the atmosphere at a rate of 15 liters per second. The diameter of inlet to the nozzle is 100 mm. The jet impinges normal to a flat stationary plate held close to the nozzle end. Neglecting air friction and considering the density of water as 1000 kg per meter cube, the force exerted by the jet on the plate is. So, in this question, a horizontal nozzle is discharging a steady jet of water into the atmosphere at a rate of 15 liter per second, and the outlet diameter of the nozzle is given as 30 millimeter and inlet diameter is given as 100 millimeter. And this jet which is coming out from the nozzle impinges normal to a flat stationary plate which is held close to the nozzle end. So, neglecting air friction and considering the density of water as 1000 kg per meter cube, we need to find the force exerted by the jet on the plate. So, this question is from the topic of momentum and energy equation. You may study about all these equation and its derivation in detail by watching lecture 10, Conservation of Momentum Application Fluid Mechanics by Professor Subhasis Datta, IIT Guwahati. So, let us recall this equation or the impulse momentum equation. So, as per Newton's second law of motion, the rate of change of linear momentum in any direction of a body is equal to the external forces acting on the body in that direction. So, if we considering the x direction and the flow is taking place as it can be seen in the figure. So, considering this as a control volume and 2 points 1 and 2, if we write the impulse momentum equation for x direction, then we may write Fx equal to ddt of mx. Further, we can rewrite this equation Fx equal to rho q into V2 cos theta 2 minus V1 cos theta 1. V2 cos theta 2 and V1 cos theta 1 are the component of velocity V2 and V1 in x direction respectively. So, here in this question we have a nozzle which is discharging a jet and which is normal to a flat stationary plate. Now, we have the value of Q which is 15 liter per second. So, if we take this equation, then we may write the forces in x direction is equal to rho. Rho is the density of water which is 1000 kg per meter cube. Q is the discharge which is given in the question as 15 liter per second, here 15 liter per second. So, in meter cube we can write 15 into 10 to the power minus 3, 15 into 10 to the power minus 3 meter cube per second into V2 cos theta 2. So, here V2 is the final velocity. So, after striking the plate, the jet will or the water will move in vertical direction, upward and downward. So, here we can say the velocity component of the water in x direction becomes 0 after striking the plate. So, this is 0 minus V1 cos theta 1. So, V1 is the velocity here before striking. So, we have the discharge value. We have the discharge value we know 15 into 10 to the power minus 3 meter cube per second, and area we know, area we can calculate pi by 4 into diameter square which is 30 millimeter. So, 0.03 square. So, we can find the velocity as Q by A which is 15 into 10 to the power minus 3 by pi by 4 into 0.03 square. So, from here we will get the velocity as 21.22 meter per second. 21.22 meter per second. Now, substituting this value of velocity here, 21.22. Now, cos theta 1. So, theta 1, since the flow or the jet of water is normal to this plate and it is striking horizontally. So, the angle with x direction is 0 degree. 0 degree. Now, when we solve this, we will get Fx, that is force in x direction, is minus 318.3 Newton. So, we got the force on the plate is 318.3 Newton. And this negative sign indicates that the force on the plate is opposite to the direction of flow. So, here we got the value of force which is 318.3. So, we can write here the force exerted by the jet on the plate is 318.3 Newton. So, 318.3 is the correct answer for this question. Thank you.